In the last video, when I gave you the rule about x going to infinity or negative infinity, I mentioned that the exponent on the x had to be a positive integer. So this is because if you have a negative integer, like x to the negative third, it means that that exponent wants to be down in the denominator. So this would be like 1 over x cubed. So when the x is in the denominator, something completely different happens. So we've got the limit as x goes to infinity of 1 over x to the n. We know from the previous video that this x to the n is going to be headed to infinity. So you've got 1 divided by something infinite. So think 1 over a billion, 1 over a trillion. It's a very, very small number. These numbers are headed towards 0. Likewise, as x goes to negative infinity, it doesn't really matter whether this x to the n is heading to positive or negative infinity. 1 divided by something huge, positive or negative, is still headed towards 0. So those new limit rules in the pink box are going to help us when we get a new kind of indeterminate form that we're going to see in this example here. So I've got the limit as x goes to infinity of a fraction. So we know limits distribute over division. So I'm going to think about these separately. Limit as x goes to infinity of 2 minus x, 2 minus something infinite, that's headed towards negative infinity. Likewise, 3x plus 5, let's think about as x goes to infinity, it's 3 times something infinite, that's still infinite. Plus 5, that's even more stuff, that's still going to take us out to infinity. So we've got negative infinity divided by positive infinity. So again, I always write these in quotes because these aren't real numbers. Negative infinity divided by infinity. This is another indeterminate form like 0 over 0, so an indeterminate form. So why is this an indeterminate form? The two always rules that we're fighting with here are when you take something infinite and divide it by something. So it doesn't really matter if it's plus or minus infinity. When you go divide it by a number, then it doesn't matter if you chop infinity into fifths or 500ths, you're still going to have something infinite. So this would still be positive or negative infinity. The denominator, we saw if you've got a number divided by positive or negative infinity, you've just got a finite number divided by something enormous. This is essentially going to look like 0. So the numerator says my answer is always infinite. The denominator says my answer is always 0. So indeterminate forms, they're fighting against each other, and we need a trick. So the trick for 0 over 0, we had lots of them, some algebra, factor and cancel, rationalizing, things like this. We had infinity minus infinity, where we did a little factoring. Infinity over infinity, the trick is going to be to divide everything by the highest exponent in the denominator. Let's write that down. So our trick for infinity over infinity, and it doesn't matter if it's positive infinity or negative infinity, infinity over infinity, you're going to divide everything by x to the highest exponent in the denominator. And that in the denominator is important, not just the highest exponent you see, but the highest exponent in the denominator. So let's try that on this one and see what happens. So the highest exponent that I see in the denominator is x to the first. So I'm going to divide everything in this problem by x to the first. I'm going to divide the whole numerator by x to the first. I'm going to kind of distribute it to all the parts. And I'm going to divide everything in the denominator by x as well. And you might be thinking, you can't just do that. You can just throw x's everywhere you want to. I can in this case, because I did the same thing on top as I did on bottom. So I essentially multiplied the top by 1 over x, and I multiplied the bottom by 1 over x. Okay, and I kind of distributed that 1 over x to both terms. And since it's 1 over x over 1 over x, this is just like when you find a common denominator and you multiply by 2 over 2. It's just a clever version of the number 1. So I haven't really changed the limit at all. All right, so now let's see what happens. I'm going to reduce a little bit here. I've got the limit as x goes to infinity, 2 over x minus x over x is 1, 3x over x will be 3, and then 5 over x. All right, so here is where our pink box comes in helpful. So anything that still has an x in the denominator, you've got a number over something going to infinity, those are going to get wiped out to 0. Okay, so my pink box tells me that this thing is headed towards 0. This thing is headed towards 0. The other two are just constants. The limit of a constant is a constant. So this ends up being a 0 minus 1 over 3 plus 0, and I get negative 1/3. Right, and you could take this function over to Desmos, 2 minus x over 3x plus 5, and as x goes to infinity, you'll see those y-coordinates leveling off at a negative 1/3. Let's try another one. This is another one that's going to end up going to infinity over infinity. We want to divide through by the highest power in the denominator. So I'm going to divide everything by x cubed. That's the biggest power I see in the denominator. So I'm going to go through and say this is the limit as x goes to negative infinity. I'm going to divide everybody by x cubed. These problems always look like a mess until you're done simplifying. So I'm dividing by x cubed. Pi, what the heck is pi doing here? All right, and then we'll be able to reduce a little bit. And again, remember, all I've done here is to multiply the top by 1 over x cubed. And I did the same thing on the bottom, 1 over x cubed. And then I just distributed it to every part of the problem. All right, so simplify a little bit. Limit as x goes to negative infinity. Never stop writing your limit. We've got, let's see, x squared over x cubed is going to give me 1 over x. 5x over x cubed is going to be 5 over x squared, and then 2 over x cubed. Down in the bottom, the x cubed over x cubed is 1. I got 3 over x squared and pi over x cubed. All right. Anything that's a number over an x as x goes to negative infinity is going to go to 0 like the pink box says. All right. And I have a lot of that going on. I've got 1 over x, that's going to go to 0. 5 over x squared is going to head to 0. 2 over x cubed head to 0. Limit of 1 is going to be 1. So I do have this 1 down in the denominator. Everything else is headed towards 0. Even pi is just a number. Pi is not so special that it doesn't get wiped out by an infinity in the denominator. And I got a bunch of 0 on top. So 0 minus 0 plus 0. And on the bottom, I've got 1 minus 0 plus 0. Okay, so I get 0 over 1, which is 0. Okay, 0 over 0 is a problem. 0 over 1 is just 0. We'll do another one of these for review when we get together in class. I know infinity is a little bit hard on the brain cells. It'll get better as you get more practice.